Hey guys, welcome back. Mr. Cockbrenner here. Solving systems of linear equations by substitution. So recently, when you guys are face to face, you guys are going, Mr. Cockbrenner, I need more algebra. This is like, we're not doing much algebra here. And I said, oh, don't you worry. Today is the day that we will show you what algebra is all about. So, substitution. When you make a substitution in a sports game, like let's say basketball, what do? You put someone in place of someone else. So that's what we're going to do today. It'll just be with numbers and letters. So before we get started, prior knowledge, how to isolate and solve for a variable. In other words, can you make it say y equals or x equals? Because remember, we do have two variables. We are just more accustomed to solving for y because y equals mx plus b. However, we can also make it say equals x or x equals. And the last thing we need to do is substituting in ordered pairs for x and y, also known as plugging in. Our goal today, number one, take a step back and recognize what is already solved for. Let's do less work than we have to, all right? Work smarter, not harder. Isolate and solve for one variable and substitute it in. And then the answer is always going to be an ordered pair. So we're going to have a little process that we're going to do throughout the video, and hopefully you can do that and replicate it on your work. So here's the thing. Instead of one equation, we now have two equations. And the first step is to recognize what's in front of us. So right now it says 2x plus y equals 8. This is called standard form. That first equation is 2x plus y, the x and the y are on the left, and it's solved for a constant. The other equation says y equals x minus 7. If you recall, we want to work smarter, not harder. So what this bottom equation says here is very, very important. All right, it says y equals. What does y equal? It equals x minus 7. So anywhere I see, I'm going to use two equations. Anywhere I see a y, I'm actually going to substitute x minus 7 in the other equation. So check this out. I'm going to sub out. Y is playing right now. I'm going to sub it out and switch and say a true statement, y equals y. And wherever I saw a y, I'm going to substitute in x minus 7. So what does that mean? This is a true statement, y equals y. And now I'm going to get 2x plus an x minus y equals 8. The nice thing about that is if you notice, I substituted out y, and now I have x in its place. It's x minus 7. With that, I substituted out the y, and now I have my x value. So I'm going to solve for x here. If you recall from when we solved equations, don't call me after midnight, that's what we're going to do here. So I have 2x plus x on the same side, so I'm just going to add those up. What is 2x plus x? It's 3x, so that's called simplifying, right? Combining like terms. And we didn't do anything to that minus 7 equals or 8. So now what do? I'm going to get that x value by itself, and instead of subtracting by 7, I'm going to add 7 to move it to the other side to isolate x, which I'm still not there because it says 3x, not just x. This is my flashcard of 0. 8 plus 7 is 15. And now we are going to divide by 3. And what does x equal? X equals 5. So again, if you recall, all of our answers are going to be in ordered pair. So the front half of my ordered pair, or my x term, is 5. How do I get my 7? I'm going to go back to that original equation where I substituted out y, and I'm going to substitute y back in. So I'm back to my original problem. And now I have a choice to make. Do I want to work harder or do I want to work smarter? I'm searching for the y value. Which of these two equations is solved for y? The second one. Exactly. So y equals, I'm going to substitute all that hard work I did right here into the problem. Here's my 5. I'm going to substitute it in. where I see x, and I'm going to get y equals 5 minus 7. Well, let's combine these like terms and have less piles over on the right side. What's 5 minus 2? I'm sorry, 5 minus 7 is negative 2. So my final answer is 5 comma negative 2. And I could plug it back into both equations to make sure that's true. 2 times 5 plus y, which is negative 2, is 8. What is 2 times 5 is 10. 10 plus negative 2 equals negative 8. Negative 8 equals negative 8. Holy smokes, that's a lot of algebra. You're right. That's why I said, for all those people who are clamoring for algebra, here is your day to shine, all right? The thing that's tricky about algebra, not going to lie, is that you can make simple mistakes. I know my cross-country crew was going, Mr. Cockburner, you made a mistake in your last video. My apologies. 12 divided by 3, I believe I said was 3. I know it's 4, but we make simple mistakes. Everybody has those days. You all know what I'm talking about. So our final answer here for this problem specifically, though, is 5 comma negative 2. So another way we can check that is by using Desmos. I just used or typed in my equations from the beginning. So 2x plus y equals 8, y equals x minus 7. I can check where we're looking for, now that we can see it visually, is where these two lines, the red line and the blue line, where these linear equations, linear functions to be specific too, where they intersect. If you look, it says 5 comma negative 2. If you look at my answer down here, 5 comma negative 2, I know that that's correct. So what we are doing when we're solving for a substitution is looking where these two lines cross or intersect, all right? It's called the point of intersection. POI is what I like to refer to it as, all right? So what we're doing with substitution, when we solve systems of linear equations, it sounds really impressive, right? So you can go home and tell your parents, hey, I learned how to solve systems of linear equations. They're going to be like, holy cow, that sounds really smart. Which all it means is what? Where two lines intersect, all right? And again, you can see how this is highlighted here. There's my y-intercept. Here's my x-intercept for that blue line. But what we're really going to focus on today is that point of intersection, that POI 5 comma negative 2. Let's try it again. Here, again, step 1 is to work smarter, not harder. Are one of those equations solved for a variable? Y plus 4 equals x. Well, that sounds like it's equal to x, right? Y plus x equals 2. That one's in standard form. So now, last time we had y solved for in this second equation. This equation, we have the top equation solved for x. So it doesn't matter which variable we choose. So what I'm going to do, again, is I manipulated this Jamboard slide so I can move these around. I'm going to take this first equation, and I'm going to take it and sub out where I see x. I'm going to take x out of the game. And what does x equal? X equals y plus 4. So I'm going to put that into the game. Now that's playing. If you want to think of it as sports. What's on the left side? We have y plus y, so I know that that's going to combine to 2y. And then I have plus 4 equals 2. Now I'm going to, again, solve for y or isolate the y. You have that plus 4. How do you undo addition? Through subtraction, that inverse operation. Now we get 2y left on the left. 2 minus 4 gets us negative 2. Make that negative sign a little bit clearer. And now that last step is going to be y equals negative 1. All right, so again, I have the power to manipulate these slides a little bit, or I sub that in, and I sub that out. Now I'm just going to rearrange back to where we were. Which of these equations is solved for? A variable, that first one. So I'm going to work smarter, not harder again, and I'm going to look here, and I'm going to plug into that first equation all my hard work to get my final answer. So again, my final answer will always be an ordered pair. I solve for y, so now I'm going to look for x. That first equation was solved for x. So I'm just going to put -1 for my y value, and now I need to find my x. How do you find your x? Plug in what you did. -1, where I have a y in that first equation. What is -1 plus 4? 3. X equals 3. So there's my ordered pair. Again, how do I check these? I go to Desmos, and I'm just going to eliminate what I just had. We have y plus 4. I don't know why that keeps popping up. Equals x. And then I also have y plus x equals 2. And you can see that point of intersection, what we proved, all of our hard work, was 3, -1. You can see that by checking your answer in Desmos. All right. So again, there is a ton of algebra in this section. That's why I, as an Algebra 1 teacher, love this. You, as an Algebra 1 student, may not love it. However, we will learn to love the simple math that we're doing. Again, what I like to stress is what we do in this classroom is adding, subtracting, multiplying, and dividing. And that's exactly what we're doing here. You just got to make sure that we are doing it in the right order and doing it correctly. So this one looks a little bit different because the first equation just says x equals 5. Well, that kind of tells me something already. What is x going to equal? So they're giving me half my answer here. However, it looks different, so sometimes people get a little intimidated. So what I'm just going to tell you is you're going to plug in wherever you see an x into the second equation the number 5. So let's just rewrite the second equation without the x term. And now we're going to substitute in that value of 5 wherever we see an x. Now, if you notice, the reason why we do that is to get x out of that second equation. Do you see an x in my new writing? No, that's because we're doing substitution. We are taking it out of the problem and substituting in front of its place. And the nice thing about this is we're only substituting one value, and that's a constant of 5. So 2 times 5 is 10 plus y equals 10. Let's get y by itself. Isolate that. How do you undo a positive 10? We subtract 10 from both sides, and we get y equals 0. That's intimidating for some people because they think 0 is not a number. No, it is. It means you don't go up or down because that's our y value. So here, we're done already. Our ordered pair is 5, 0. How do you check this? Go to Desmos. All right. X equals 5. Oh, man. And then we're going to get 2x plus y equals 10. And if you look at that POI, it's 5, 0, just like we got with our algebra here. All right, so we're going to just check with Desmos. Again, the reason why we did this problem is because it looks different. Anytime things look different, you guys kind of freak out, and that's why I'm going over specific problems. So that first problem, we had y solved for here. The second problem, we have x solved for here. The third problem, we're missing our mx term. So that's why I did that one. Again, stop and recognize what's solved for here. y equals x plus 4, y equals negative 2x plus 1. This one's tricky because what? Good, both are solved for y. So no big deal. It kind of looks weird because you're going to have stuff on the left and stuff on the right. However, what we're going to do is I'm going to take this first equation, and wherever I see a y, I'm going to sub in for that value what y equals in the first equation, which is x plus 4. So this y now is x plus 4. I'm going to copy everything else down. And again, if you look, the first step is to recognize what's given to you. I recognize that both were solved for, y, so that's a good thing. And then I substitute in second. So now what I'm going to do is move my x's to the one side, move my constants to the one side, and make sure I get x equals something at the end. So I'm going to move this negative 2x, move the smaller of the x terms. So we're dealing with positive numbers. So now we're doing step 2, which is solving for a variable. Here I get 0. Now I'm left with positive 1 over here. What is this flashcard here? X plus 2x is 3x. I didn't touch positive 4, so I just rewrite that. Now I'm trying to get that x all by itself on the left. It's being multiplied by 3 and added by 4. We're going to keep that bestie to the end. Don't call me after midnight. If you guys want to think of it that way, you can. Again, this is 0, so it's eliminated on that left side. You guys love this step. You guys don't have a problem with that step of isolating that x value there. And we get x is negative 1. Again, remember, every answer is an ordered pair. So first we look, second we solve for a variable, and now we plug it into one of the equations. You have the choice to plug into either one of these equations. I always try to choose the easier route. I think y equals x plus 4 is easier because there's no negatives. So y equals x plus 4. And again, I'm not going to copy the x down. I'm going to substitute back in all my hard work down here into that answer. And now I'm going to combine like terms. Negative 1 plus 4 is positive 3. All right. So again, you can go to Desmos. I don't know. It's acting up as far as that keyboard keeps popping up. So I'm not going to check it. You guys can check it. I've done this work prior to recording the lesson, and I can see from my prior work that I do have the correct answer, negative 1, 3. But I would always check Desmos to see where those two lines intersect. All right. Y equals 3x, x plus, or 5x plus 2y equals 44. This one looks different because we're missing a constant. So with that being said, I'm going to use this first equation because I'm going to look before I do anything else and say, hey, that has a variable solved for. This one is in standard form, right? X and y on the left, constant solve for on the right. So let's look here. Wherever I see a y, I'm going to substitute what in for it? What does this first equation say? Y equals 3x. So instead of writing y, I'm going to substitute in 3x. When I do that, I'm actually substituting out the y values and putting in x values. So it's just like in a sports game, I'm going to substitute something out, but then put something else in its place. And the reason why I'm doing that is because I'm getting rid of that y term. I'm subbing it out and putting x in its place. So now let's do, don't call me after midnight. Let's distribute first. 5x plus 6x equals 44. Just as a math brain, I like these combination because 5 plus 6 is 11x. And I know 11 goes into 44. How many times? 4 times. So there, I have half my answer. I have x equals 4. It's the front number of that ordered pair. Now I have a decision to make. Do I want to put it in the first equation or the second equation? If you put it in the second equation, you like doing more algebra than you have to. I'm going to tell you work smarter, not harder. Y equals 3 parentheses. What goes in the parentheses? All your hard work. All right. Y equals 3 times 4 is 12. And again, just from doing prior side notes here, I know that that is the correct answer. I would tell you right now, plug it into Desmos, please. If it's working properly for you, for some reason my screen keeps messing up, so I'm not going to check it. Any questions there? Again, look at what is solved for. Then we are going to substitute in, wherever we see a y, that 3x. All right, we're going to solve. We are then going to choose which option to plug it back into, and then we're going to get our answer as an ordered pair all the time. Y equals 5x plus 2, y minus 5x equals 2. So stop, look, which one solve for. The first equation says y equals good, so wherever we see a y in the second equation, we're going to substitute 5x plus 2 in its place. So I'm going to substitute this for that. So instead of y in this second equation, I'm going to write 5x plus 2. And now I'm going to copy the rest of this down, which is negative 5x. Don't forget that negative, very important. And now I'm going to combine like terms like I always do. All right. We have a 5x minus the 5x, which is something interesting. What does 5x minus 5x get you? 0x. So we don't have any more x's. They simplified out. So we get 2 equals 2. What does 2 equal 2? What does that mean? Yeah, they're equal to each other. So this is a special case. What's so special about it? They what? They equal each other. So let's show that on Desmos. So I'm going to erase those. And our first equation says y equals 5x plus 2. And then our other equation said y minus 5x equals 2. So y minus. So if you notice, when I graph these, what happens is that we have all these silver dots because those are all points of intersection. So if you look real quick again, that blue line changes into the green line. You see that? Meaning what? That these two equations are equal to each other. How many solutions do they have then? They have infinite solutions. All right? They're the same line. They have so many solutions because they touch the whole time. So again, we could see that when we first graphed it. You can see all these silver dots popping up because those are all points of intersection because they're the same line. All right? They're just written in a different order, right? Y minus 4x plus 5 equals 0. 4x equals y minus 1. So this is a little bit tricky because none of those equations are solved for. So this is where we had to solve for an equation or solve for a variable. I'm going to manipulate this first equation and get y by itself. No, you know what? I'm going to do the second one because it's a little bit less work. So I need to move. I'm going to make this say equals y. So I need to move this negative 1 to the other side. How do you move a negative 1 from the right over to the left? Add 1 to both sides. What is 4x plus 1? Just that, 4x plus 1. What is negative 1 plus 1? That gets you my 0 here. And I'm left with y equals 4x plus 1. All right? So now, since I have a variable to solve for, I'm going to substitute that in. What does y equal? 4x plus 1. So anywhere I see a y in this equation, I'm going to substitute the y out and put 4x plus 1. So the very first thing in that problem is a y. So instead of y, I'm going to put 4x plus 1. Two things are going in that one spot. You're right. That's okay. Minus 4x plus 5 equals 0. I just recopied everything else behind what I just substituted for. So now I'm going to combine like terms. On that left side, I get 4x here and negative 4x here. Same thing. Special case, right? Because now I'm going to get 1 plus 5. Simplify those, you get 6 equals 0. Is that a true statement? No, that does not equal each other. So this is a no solution problem. What do you think that means? When I graph it in Desmos, what's going to happen? I'm going to get y minus 4x plus 5 equals 0. And then I'm going to get down here. My original problem was 4x equals y plus 1. And if I look on my graph, you can see that these lines never what? They never touch. What does that mean? That they don't have any points of intersection, meaning they have the same slope. So this is a no solution. So we have a special case when they're the same line. We have infinite solutions. And we have a special case when they have the same slope, that they do not have any solutions. 2 more word problems and we're done. All right, the length of a rectangle is 3 more than its width. The perimeter of the rectangle is 58 centimeters. What are the rectangle's dimensions? So next to it, I have what we are looking at. Width are the sides, lengths are the top and bottom. Perimeter is 2 times L plus 2W, so that's going to help us out here. That first statement, I know we don't like to read, but that's going to be one of our crucial points that we kind of emphasize here in Algebra 1. We know you don't like it, so we know we're not very good at it, so that's why we're going to attack that and make sure that we can do it, because it's like Scooby-Doo. We're looking for clues, jinkies, right? The length of a rectangle is 3 more than its width, so length is what? 3 more than its width, so W plus 3. Does that make sense? 3 more than width, so W plus 3. The perimeter of a rectangle is 58 centimeters, so the perimeter is 58 2L plus 2W. All I did was substitute the information right here into the perimeter, all right? So if we look here, I need to turn off my notifications, my bad. Little shout out to Liam and Zariah there. L equals W plus 3, 58 equals 2L plus W. What does this equation solve for? Good, L. So what I'm going to do is wherever I see an L in that second equation, I'm going to substitute what's on the right side, that expression, W plus 3. All right, so now what do? Don't call me after midnight. Distribute. 2 times W, 2W, 2 times 3, positive 6. I simplify that. Whatever I don't simplify, I just rewrite. Now we're back to these problems. Do you see something missing from that equation now? An L, yeah, because you substituted it out with a W plus 3. That's a good thing. So now what's 2W plus 2W? 4W. So we went from 2 piles to 1. That's what we're doing. It's called simplifying through addition. Now we're going to get W by itself by subtracting 6, keeping its best friend there. What is 58 minus 6 is 52. This is 0, so now we're left with 4W. I'm just going to write it over here. 52 equals 4W. How do you undo multiplying by 4? Through division. Again, all we do in this class is add, subtract, multiply, or divide. 52 divided by 4 is 13. All right. So now we have to find the length. And if you recall, what's our length? From over here, it's W plus 3. Right? Just check my math. So that gets you my 13. Our length is going to be 13 plus 3, getting me my 6. Oh, sorry. Giving me my L. L equals 16. All right. Any questions? So again, we're going to have our width and our length. 13 and 16. Any questions? Last problem. A professional organizer charges a $45 consultant fee plus $20 per hour. Her competitor charges $30 and $30 consultant fee and $26 per hour. So what does this look like? We're getting pretty good at this. Y equals 20 per hour plus the initial fee of $45. The competitor is Y equals 26 per hour, so they're a little bit more expensive per hour, but they're a little cheaper up front. So now what do you notice? Both are solved for a variable. Good. So it doesn't matter which one we're going to substitute in for. We know we're going to substitute y's out, however. So I'm just going to box this up. Wherever I see a y in this equation, I'm going to just flip-flop those. And now I get 20h plus 45 equals 26h plus 30. All right, I'm going to move the smaller of the h quantities first. I'm going to move 20 because it's smaller than 26, just so I stay positive with my h values. That's 0. I'm left with 45 on the left. 26 minus 20 is 6h. I didn't touch that 30. Now I'm going to move 30 from the right to the left through inverse operation. Again, a bunch of adding and subtracting. Welcome to algebra. And I'm going to get 15 here, 6h here. If I go here, I divide by 6 because I'm going to solve and isolate h. What is 15 divided by 6? That's a fraction, right? So let's look at that. Let's just get that out of here. 15 divided by 6. So 2.5 hours, right? So what does that tell you? That these two are equal at 2.5 hours. So what does that mean? After 2.5 hours, it's going to be cheaper to go with the $20 per hour. And if it's under 2.5 hours, it's going to be cheaper to use the competitor. So it sounds like the competitor will be cheaper for 2.5 hours or less. I should say less than 2.5 hours. And then the professional organizer who charges more up front but less per hour will be better for 2.5 hours or more. All right. Just to recap what we did, take a step back and recognize. Isolate and solve for one of the variables. Normally they're already solved for. That's a good thing about substitution. And our answer will always be an ordered pair. All right. Other than that, again, like we always say, pause, rewind, repeat, right? And hopefully this is a lot of algebra and will be probably one of the most algebra in-depth classes that we have for the whole year. So you got it done and over with. Hopefully it makes sense. If you do have a question, please email myself, Mrs. Thomas, Ms. Seferati, and you should be good to go. All right. Subscribe, thumbs up. Go Browns.